Hi gang. Today you're going to learn how to find the pH of a weakly soluble base. In order to do that, you're going to need to be able to do a couple of things. You're going to have to use the Ksp value and the rice table. Some teachers call that the ice box. I go with the rice table. You're going to need to use these to find the concentration of hydroxide ions. Once you have that, you're going to use that to find the pOH and then the pH. That's the whole goal. It's a lot of setup just to get from there, but this is what we have to do. So let me give you an example. Okay, here is a mythical, magical MOH2. Doesn't exist, doesn't matter. This is going to dissociate. The M ion has got to take a +2 charge. I know that because there's two hydroxides, so this takes a +2 charge. When it dissociates, I get M +2 +2 hydroxides. There's my reaction for the rice table. Now I need my initial concentrations. Well, this is a solid. That's the whole point. It's only weakly soluble. So we're going to ignore that for the initial concentration. We're going to set these guys equal to 0. If you really know your pH or pOH, you know this isn't true. Don't worry about that. Skip that. Now, the change. We're going to be losing some of these molecules as they break apart. And for each one of these that breaks apart, I'll get one of these. I don't know how many that is. That's S. So I'm going to gain plus S, M +2 ions. Then, again, for each one of these that breaks apart, I'm going to get 2 hydroxides. So that's plus 2S hydroxides. My ending concentration, don't care, because this is a solid. These are the only two things that are aqueous. This is going to be S and 2S. So now I have set up my rice table to help me set up my Ksp expression. So the Ksp expression, in this case, it's my products, these two ions, so the concentration of M +2 times the concentration of hydroxide ions squared. This 2 gives me that 2. Now, if this was a normal K, I might put a fraction and put the reactants, but that is a solid, so we don't include that in the K expression. Now we can go ahead and we can substitute in our S and our 2S. Remember, though, that the 2 and the S get squared. So this term reduces down to 4S cubed. At this point, you need the Ksp value. I haven't given it to you yet. Since I'm making up an element, I can make up a Ksp value. I can do that. So the Ksp value I have made up for you is 5.25 times 10 to the minus 10th. So now what we can do is we can set that value equal to that. We're going to solve for S. I'm going to show you how. That will give us the start for our concentrations. Okay, so now I'm back to, I have my value equal to my variables. I'm going to solve for S. Now you should know from algebra that we're going to have to divide both sides by 4 and then take the cube root. The way you should plug this into your calculator, you do it all in one go. Parenthesis, 5.25, use the E button, e to the negative 10, divided by 4. That in the parentheses, and a lot of calculators don't have a cube root, but most of the time, calculators, you can use the caret button to raise to the power of 1/3, which is the same thing as taking the cube root. This gives us a value of S equal to, I wrote this down over there, 5.08 times 10 to the minus 4th, and these would be in molar. But from the rice table that I erased, this is not the concentration of hydroxide. The concentration of hydroxide is 2S. So that is 1.016 times 10 to the minus 3. Now, POH, just like pH, except you just have to pay attention, so it's going to be negative log equals negative log concentration of hydroxide ions. And when I punch this into my calculator, I come up with 2.993. pH is 14 minus POH, which in this case gives us 11.007. Okay, that was a lot. What do you need to be able to do? You need to set up your rice table. You're going to use your Ksp value once you have the expression from the rice table. Solve from your S. Remember to turn your S into the concentration of hydroxide. Find the POH and use that to find pH. Good luck.